Hello everyone, welcome to another series on Snowflake for data engineers. Data is like gold for businesses. Because of fancy technologies, we are dealing with tons of big data. Storing and managing all of that info has become big deal for businesses to run smoothly. And one such popular tool is Snowflake. It helps data engineer to create data warehouse and data lake platforms. In 2012, Snowflake came into tech scene and it's not your regular software. It's like a digital superhero. It's a managed SaaS service and it's like one-stop shop for everything about data. We are talking about storing data, managing big data set, doing techy stuff with data, and even creating applications with it. Snowflake is a cloud data platform. To be more specific, it's a first cloud-built data platform. Its architecture allows data specialists to not only create data warehouse but also create cloud-like lakehouse because it manages both structured and non-structured data. It can make use of AWS S3 as a storage layer. Hence, cloud and compute remains separate. Business analysts can easily make use of Snowflake to create their marketing, finance or other decisions. Data science can use this to create their ML model and create the features easily. Now, what makes Snowflake cool? Well, it has some built-in features that are like magic tricks. It keeps storage and computing layers separate and can scale up and down as needed. It can share data like a pro, make copies of data on spot, and place valid tools from other companies like Tableau and Power BI. What makes of Snowflake platform? Snowflake is designed with three main components: cloud services, query processing, and database storage. Cloud services. Snowflake uses ANSI SQL for cloud services, empowering users to optimize their data and manage their infrastructure. Snowflake handles security and encryption of stored data. Query processing. The compute layer of Snowflake is made of virtual cloud data warehouse that let you analyze data through request. Each Snowflake virtual warehouse is an independent cluster and do not compete for computing resources nor affect the performance of each other. Database storage. Snowflake database is where the organization uploads their structured and unstructured data. You can make use of AWS S3 or Azure Data Lake storage. That helps us to scale our Snowflake database layer unlimitedly. There are lots of opinions when it comes to cloud data warehouse. Everyone have specific use case. Snowflake is cloud agnostic. Snowflake is not limited to specific cloud provider. We can scale out databases or data warehouse across AWS, Azure, and GCP. Snowflake is built for performance, starting with underlying infrastructure that is built to run analytical queries. To add to that, the elastic nature of cloud means it will help loading data faster and run high volume of queries and concurrent queries at the same time. You can scale up your virtual warehouse to take advantage of extra compute resources. Now let's go ahead and log into Snowflake console. Now it's time to create Snowflake account. Snowflake provides 30-day free trial version. We'll go ahead and create account for 30 days free trial. For creating an account, go to snowflake.com, click on start for free. Fill the details here. click on continue. Snowflake comes with 3 editions, that is standard, enterprise and business critical. Standard is a strong balance between features, levels of support and cost, whereas enterprise provides standard plus 90-day time travel, multi-cluster warehouse and materialized view. We'll be discussing about time travel, multi-cluster warehouse and materialized view later on in the playlist. And it also comes with business critical, that is enterprise plus enhanced security, data protection and failover and fallback. For our playlist, we'll be going ahead with enterprise edition. We can choose any of the cloud provider. For this video, I'm gonna choose AWS and I will leave Asia Pacific Singapore as default. Let's go ahead and create started. We can skip. Now we are successfully signed up. You would have received the email regarding the invitation link for Snowflake. This is the email to activate an account. You will be asked to create a username and password. Since I have already created username and password, I can directly log in. This is the Snowflake dashboard. You will have worksheet, dashboard, streamlit and so on. We'll be exploring all the features one by one in our upcoming videos. Snowflake provides us some sample bookmarks that will help us to learn and get started with Snowflake. This is our worksheet section where you can go and create our own worksheet and run scripts in Snowflake. That's all for this video, guys. From our next video, we'll get started with Snowflake. Hello everyone, welcome to this video where we'll discuss on Snowflake's key concepts, warehouse, databases and schema. In today's video, we'll break down these concepts, provide clear explanations and support everything with hands-on labs. Snowflake is cloud-based data platform designed for simplicity, scalability, and performance. It allows organizations to store and analyze large volume of data effortlessly. Today, we are focusing on 3 core concepts or backbone of Snowflake called warehouse, databases, and schema. Before we dive into details, let's quickly understand Snowflake architecture. It follows multi-cluster shared data architecture where compute and storage are separate. This unique approach enables Snowflake on-demand scaling and ensures optimal performance. The main thing in Snowflake begins with Snowflake Data Warehouse. This is the computational engine responsible for processing your queries. You can think of it as powerhouse that handles all computation in Snowflake. Warehouse in Snowflake can be on-demand or virtual, and you can pay for the use of resources. The main component is data warehouse. Inside a warehouse, we can have databases. Inside databases, we can have n number of schemas, and each schema can consist of n number of tables. Go ahead and create our first warehouse, databases and schemas. This is our Snowflake dashboard. We can see that we have 6 roles available as of now. That is account admin, organization admin, public, security admin, sysadmin and user admin. We'll discuss about each roles in detail in our next video. As of now, let's select account admin. We are selecting account admin because account admin has a privilege to create schemas, databases and warehouse. If you are coming to dashboard for the first time, we can click on plus and create our own SQL worksheet. As I have already created the worksheet, I am going to dw_db_schema named warehouse worksheet. These are the available database as of now. We can write our script here. We are creating a warehouse named my warehouse with the size extra small. Our warehouse can be of many size, extra small, small or large. Then we are using auto suspend to 600 seconds. That is, if our warehouse is inactive for 600 seconds, it will automatically terminate our warehouse. Auto resume equals to true. That means after 600 seconds, if we are running any query, it will automatically initiate our warehouse. Let's go ahead and create a warehouse. To run a query, click on this blue button. Now we can see that our warehouse is successfully created. And to see the warehouse, we can go here. We have two warehouses as of now, compute WH, which is extra small, and my warehouse, that is also extra small. To change the warehouse, click on my warehouse. Now our my warehouse is created. To create a database, click on this command. Select this command, that is create database mydb, and run this. Now our database is successfully created. Within this Snowflake database, we can organize our data using schemas. Schema is a way to logically group related databases into tables and views. It is like creating a folder for better organization. To see all the available database, let's go back and go to data. We can refresh this page. We can see that MyDB database is available now. The source is local and the owner is account admin. We can see that we have shifted our role to account admin, so we are able to create our database and warehouse. And we can see the schema. As of now, we have public and information schema. Information schema is used to store all the information, what type of table it is, when it is created, all those details. And public is available schema as of now. We can go ahead and create our custom schema as well. A schema is a logical grouping of databases, tables and views. Each schema belongs to single database. To create a schema, click on select this command and hit enter. That is create schema my schema. Now we can see that our schema is created. Let's see inside our MyDB. We have to refresh the page first. Let's see inside our MyDB. We can see that a new schema named my schema is created. We can see the definition as well. Create or replace schema, that is this. To sum it up, in Snowflake, we have created warehouse for computational tasks, a database as a logical container, and schemas to organize data within our database. These components will work together, providing us scalable and powerful data platform in cloud. Thank you. Do like, subscribe, and share with your friends. Hello everyone. In this video, we'll discuss about Snowflake system roles. This is the Snowflake dashboard. If we are clicking here, we can see the option switch role. These are some of the default roles provided by Snowflake. They are account admin, organization admin, public, security admin, sys admin, and user admin. We'll be discussing them one by one. We can also create our custom roles. Snowflake roles are the entities that can grant and revoke privileges on objects. Objects can be things like warehouse, databases, schema, or tables. Users are assigned roles to allow them to undertake actions required for their business functions. Users can have several roles assigned to them. Users can switch roles to conduct different actions with different set of privileges. Access to secure objects is granted in Snowflake by privileges allocated to Snowflake roles, which are then assigned to other roles or users. Furthermore, each sequerable item has an owner who has the authority to grant access to other Snowflake roles. This concept differs from user-based access role model in which users or group of users is allocated right and privileges. The Snowflake approach is intended to provide you with lot of control as well as lot of flexibilities. In Snowflake account, there are just few system defined roles. Snowflake roles that are defined by system cannot be removed. Furthermore, Snowflake rights granted to these positions cannot be removed. Additional privileges by system defined roles can be granted, although this is not encouraged. There are 5 different system roles. Let's talk about each one of them one by one. First is account admin. This is the highest level of Snowflake role. It should be heavily limited in access and encapsulates system admin and security admin. Security admin. This role is used for managing any object grant globally and therefore is granted the manage grants privilege by default. This role also inherits the user admin role. User admin. This role is dedicated to user role management. By default, this role can create, modify users and their respective roles, assuming those roles or users haven't been transferred to another role. Then comes system admin. This role is dedicated to system object management. It is recommended by Snowflake to assign all custom role to the system admin. So this role has granted these privileges to other roles. Next comes public. This is a pseudo role that every user or role in the account gets. Things owned by the public role are public. Consider the following scenario for more detailed example of role hierarchy. Role 2 has been assigned role 3. Role 1 has been assigned the second role. User 1 has been assigned role 1. Now, in this scenario, role 2 incorporates the privilege of C. Role 1 incorporates the privilege of B and C. User 1 has all the 3 privileges. That is, user 1 has the privilege of A, B and C. Let's now go ahead and create user and assign role to the user. This is a Snowflake UI. As of now, we can see that under switch role, we are 6 default roles: account admin, organization admin, public, security admin, sys admin and user admin. Let's go to roles worksheet. Let's create a table first name car sales CSV. Now I will assign select privilege to this table for our user that we are creating. Let's create a role first, that is marketing role. Now we want to grant our marketing role a privilege to perform select operation on car sales CSV table. To do that, we can use grant select on table car sales CSV to role marketing role. Now we can create a user, alter its email ID and grant this role to the user. So our statement is successfully executed. In this way, we have assigned our marketing user the select operation on this TV. Same way, we can create analyst role and create a password, assign a username and email and provide a appropriate permission to this user. To drop the user or role, we can use drop user marketing user and drop user analyst role. To see which all roles are created, we can just write show roles. So here we can see that a marketing role is created. By default it's N, it's not a default role, and is current N, no one is using it. And is it assigned to user? It says 1, that is it is assigned to one user. To shift between role, we are using account admin as of now. We can use role org admin. So this way we can shift between roles. Now we can see it is changed to organization admin. This was the hands-on on roles and privileges in Snowflake. In this video, we have understood Snowflake roles and gave an overview of access controls, which provides vital when defining roles and giving access to the user. The process is very important for the organization's own benefit, and it establishes clear boundaries in terms of what information is accessible to which user. Hello everyone, we'll now go ahead and load data from AWS to Snowflake. I have already written the script for loading the data from AWS to Snowflake. Let's go ahead and run the script in Snowflake. We have to first create a database. Let's switch to newly created database. So the data we'll be using for the project is from Kaggle repository, that is used car price prediction by CarDeco. The data consists of car name, year, selling price, present price, kilometer driven, fuel type, seller type, transmission, and owner. So we have created the schema of the table, that is car name, varchar, year, number with 4 number of integer and 0 after decimal place, then selling price, present price as number, kilometer driven as number, fuel type as varchar, and so on. Now our table is created successfully. Next, we need to create an integration object. This integration object will help us to connect our S3 with our Snowflake. For doing that, first we have to create a IAM role, then we have to create a S3 bucket and put the location here. Let's go to AWS console and create a role. Let's go to IAM. To create a role, let's go to roles. Click on create role. We can create a role of different trusted entity type. For doing this, let's go to AWS account. We have to create a role for this account. Let's go to next. Our Snowflake needs full access of our S3. So let's give Snowflake S3 full access. Let's go to next. Now let's provide a role name. We can also provide a description here. Let's go ahead and create role. Now that our role is created, we can see that we are attached with Amazon S3 full access, and there is something called trust relationship. We need to edit this to create a successful relationship between Snowflake and S3. Let's now go ahead and create S3 bucket. Let's go to S3. Let's click on create bucket. Let's provide an appropriate bucket name. Let's leave everything by default and click on create bucket. Our bucket name is not unique. We cannot put underscore, so let's put this. We have now successfully created the bucket. Let's go ahead and create folder for CSV files. In our next video, we'll be seeing how we can connect to JSON file and Parquet file as well. So I'm creating a folder named CSV files. Let's copy this S3 URI and go to Snowflake and paste it here. And let's copy the ARN from here in our IAM role and paste it here. So what we are doing, we are creating a external stage. Since our data is present in S3 bucket, we have to create a type as external stage. Our storage provider is S3 and it is enabled to true, and our ARN is we have taken from IAM role and we have taken the S3 location allowed from S3 bucket. Let's now go ahead and create an integration object. Our integration object is successfully created. Now let's see the description. We can see the description of our integration object. The most important part is 5th and the 7th one. Now let's go ahead to our IAM role and edit our trust policy. We can copy this storage AWS IAM user ARN from here and paste it here. This will help to connect our S3 to Snowflake. Now we have to add a condition. We have to condition as external ID. Let's leave it by default, and string equals this one. This is the external ID of our Snowflake account. Now click on add condition and click on update policy. Now we have successfully created a connection between Snowflake and S3. Let's go to Snowflake. Now our integration is done. Now let's go ahead and create a file format to read a CSV file. Our type is CSV, our delimiter is comma, we are skipping the header, and if it is null, we are typing null. Now our file format is ready. Now we have to create a stage. We have to provide a URL here. Let's copy our S3 URI and paste it here. Now our Snowflake stage is ready. Now it's a time to ingest the data from S3 to our Snowflake. To do that, we can make use of copy command. Now we are moving our data from stage, and whenever there is any error in any row, it will just continue. Skip that row and continue to the next row. It is taking some time. It have taken nearly 4.2 seconds to complete this query. Now we can select the data. We are not seeing any data because we have not uploaded our CSV file to our S3 bucket. Now our data is successfully uploaded. Now to get the data, we have to copy data from our S3 to our Snowflake. We can see that it has successfully loaded 301 rows. Now I do select star from car cell CSV. We can see data that is loaded. In our next video, we'll see how we can load our Parquet and JSON type data. Like, subscribe and share with your friends. Thank you. Everyone, in this video, we'll discuss about type of table in Snowflake. There are three types of table in Snowflake. They are permanent table, temporary table, and transient table. Understanding the difference between permanent, temporary, and transient table is crucial for efficiently managing data in Snowflake. It helps in aligning storage choices with specific use case and also helps in optimizing cost based on lifecycle and requirement of data being processed. Let's first understand about permanent tables. Permanent tables in Snowflake are persistent storage structure for structured data. They are created to store data for long term. Data in permanent tables is stored in Snowflake's cloud-based storage, ensuring durability and accessibility. These tables are suitable for storing data that needs to be retained and queried over extended period of time. Permanent tables are integral to data warehousing and analytics, serving as a primary repository for structured data. It have high level of timetable retention in comparison to transient and temporary table. It also have fail-safe period of 7 days. Let's now move to temporary tables. Temporary tables are designed for short-term storage needs that are automatically dropped at the end of session or transaction. Temporary tables are useful for storing intermediate results or temporary datasets being queried, data transformation, or other short-term operations. They are session-specific or transaction-specific, ensuring that they do not persist beyond the scope of ongoing computational activity. Temporary tables contribute to efficient query processing by providing a local storage space for interim use cases. Once the session ends, data stored in table is purged completely and is not recoverable, either by the user who created the table or by the Snowflake. We can create temporary and non-temporary tables with the same name, but within the same schema, temporary table takes more precedence over any other table. Let's now move to transient table. Transient tables are optimized for short-term storage of large dataset and are built separately from permanent tables. These tables are suitable for handling intermediate dataset during data processing tasks, offering a balance between performance and cost effectiveness. Transient tables are automatically deleted after the specific time period, providing a mechanism to manage cost associated with temporary storage. They are particularly useful in scenarios where large amount of data need to be processed and retained temporarily without incurring long-term storage cost. It does not have additional fail-safe cost because it does not provide a fail-safe mechanism like permanent table. We can create transient table and databases and schema as well. All tables that are created in transient schema as well as schemas that are created in transient database are transient by definition. We have discussed about permanent, temporary and transient table. Let's now move to practicals in our Snowflake UI. I have already written the script. I'll attach the script in the description. Let's first create a database named practice. Now let's get started with temporary table. To create a temporary table, I have to mention temporary table, that is create or replace temporary table and the table name. Now our temporary table is created. I can insert the data inside this table. Now if I am going and doing show tables, we can see the details of the table, that is when it is created, name of the table, database created in, schema, and kind. Under the kind, I can see it's mentioned it's a temporary table created by account admin and so on. You can see the other details by scrolling towards the right. Now if I am doing select star from card stamp, I can see the record. Now as temporary table says, the data is not available in any other session. So if I copy this query and open a new session, it is new SQL worksheet, select database name practice, and run the same query, I am getting an error saying SQL comparison error. This is because the table is no longer available in this session. Now let's go and create transient table. To create a transient table, I have to mention transient here. Create or replace transient table, table name, and the variables. Now if I am creating a transient table, it's successfully created. I can insert a data inside a transient table using the same command. Now if I do show tables, we can see that under the kind it's mentioning temporary or transient. So this is how Snowflake gets to know what kind of table it is. Now if I am doing select star from card transient, I am able to see this. If I copy this data and put it in another session, I can still see the data. So this is a difference between temporary and transient table. That is, transient table is available in another session, but temporary table is not. Now let's go ahead and create a permanent table. To create a permanent table, we don't need to do anything. The default type of the table is permanent. Just create or replace table. Now our permanent table is created. Same way, I can insert the data inside the permanent table. Now if I am doing show tables, now I can see, under the kind, if it is permanent table, it just says table. This is because default type is permanent. Then comes temporary, then comes transient. Now if I am doing select star from cards permanent, I am seeing the data. And I can see the data if I am going to another session as well. Now like this, we are not able to understand the difference between transient and permanent table. The only difference between transient and permanent table is fail-safe mode is available in permanent table, but fail-safe mode is not available in transient table. So if you are having a security concern and all, permanent table is the best fit. Now there is also a way by which we can change the table, that is we can make permanent table to transient and transient table to temporary. So now if I am doing that, create or replace transient table, then I have to clone it. This is a way I can create a transient table out of a permanent table, that is create or replace transient table. I am writing a table name cards transient clone cards permanent, and I can drop a permanent table now. That way, if I am writing a query show tables, and if I am running this, now I can see clone is created and clone is transient in nature. By this, we have created a clone of permanent table which behaves as a transient. Now I can go ahead and drop my permanent table. I can also create a clone of transient table into a temporary table. To do that, we can just write create or replace temporary table cards temporary clone cards transient. By this, we are creating a clone of transient table as a temporary table. So it's already dropped. So if I'm just doing, I've already run the query, that's the reason I'm getting a compilation error. If I'm showing the table, I am seeing that our car's temporary clone exists and it is temporary in nature. In this video, we have seen how we can create temporary, permanent and transient table. We have seen what are the differences between all these tables, and we have also seen how we can clone one tables into other types. Hello everyone, in this video we'll discuss about time travel in Snowflake. When we talk about time travel in Snowflake, we are not talking about hopping into a time machine like in movies. Instead, it's like having super organized system that keeps track of changes made to a data over time. Snowflake automatically saves different versions of your data so you can look back and see how things were at different point of time in the past. You can ask Snowflake to show you what the data looked like at a specific time in the past. It's like looking at the snapshot of the information as it was in particular point of time in the past. Snowflake keeps the historical data for a certain amount of time, which you can decide. It's like having a record of changes just in case you need to check what happened or analyze how things evolved over time. Using time travel, you can perform following action within the defined period of time. Query data in the past that has since been updated or deleted. Create clone of entire tables, schema and databases at or before specific point of time in the past. Restore tables, schemas and databases that have been dropped. Once the defined period of time has elapsed, the data is moved to Snowflake failsafe, and this action, like retrieving the deleted or dropped data, can no longer be performed. Time travel cannot be disabled for the account. A user with the account admin can set data retention time in days to 0 at the account level, which means that all the databases created in the account have no retention period by default. However, this default can be overridden at any time for the database, schema, or a table. To support time travel, the following SQL extension can be used. They are select at before, clone at before, and undrop. At and before are the clause that can be specified in select statements, create statements, and clone commands. The clause uses one of the parameters like timestamp, offset, and statements. Undrop command for tables, schema, and databases can also be used to retrieve deleted tables, schemas, or databases. Time travel retention period can be set between 1 to 90 days. After that, data moves to a failsafe period. We'll be discussing about failsafe in our next video. Let's now move ahead and see the demonstration of time travel retention in Snowflake UI. Create a database named practice. Inside this database, in a public schema, let's create a table named cars. Now, while creating a table, we can see we have set data retention time in days to 90. This basically means we are setting our time travel to 90 days. Now, if I am doing show tables, I can see that my retention period is set to 90 days. Now, I am creating one more table named card test, and I am providing data retention time in days to 95 days. Now I am getting an error saying exceed maximum allowable retention time 90. So we have used enterprise level of Snowflake account, and while creating the account we have already seen our time travel maximum allowed time travel time is 90 days, so we cannot make it to 95. We can alter the time travel of the cars table using a command alter table name set data retention time in days to 30. Now my time travel days is set to 30 days. Now if I am going and doing a show tables, I can see my retention time is now set to 30. If retention period is changed for account or individual object, then retention period will be changed for all the lower level objects. What that basically means, if we are changing a retention period of any schema, then by default all the table created inside that schema will have same time travel dates as that of the schema if it is not explicitly defined. Let's create a schema called car frame. Now let's create a table car frame. We have selected car frame schema. Let's create a table car frame with data retention time is 90 days. As of now, we have not set any data retention time period for this schema. So if I'm inserting any data inside this, and if I'm doing show tables, I can see that my cars new has a retention period of 90 days. Now let's go ahead and alter the retention time period for our schema to 55 days. Now we have selected the schema car frame and let's create another table name car2. Now if I am doing a show tables, for car2 I have not set any data retention time period. Now if I am going and seeing the retention period, I can see that my car2 has a retention period of 55 days, that is same as the schema time period. So yeah, there's one more way to see the information schema of the tables present inside the specific schema, that is this select star from practice.information schema.tables where table schema is car frame. So using this command also I can see the details of the schema or the tables inside the schema. Let's now go ahead and query our data by using specific timestamp. Let's select our current timestamp, that is this. Let me copy this timestamp. Now let's set our timestamp by default to UTC. Now let's see our data by using our timestamp, right? Okay, now let's see our data. So we can see some 8 records which I've recently added. So let's go and do 30. Now I can see that time travel is not available. That is because I have created a table just now. That's the reason it's giving me error. So this is the way. If I'm just giving 33, maybe data may be available. So it's again the same thing. 36. Right? Yeah, I'm getting a data. So by using this I can go to specific timestamp. Now I can also go by 7 minutes. That is, I'm going back to 7 minutes. It's giving me error. Let's go by 3 minutes. Since I have created a database just now, I'm not able to query it. Yeah. Let's query by 4 minutes. So by using this I can just query my data. Now let's also understand about dropping and restoring object. When the table, schema or database is dropped, it is not immediately overwritten or removed from the system. Instead, it is retained for specific time travel days that we have set for that schema or database. So once data is dropped within the time travel days, I can restore that. Let's now go ahead and drop this schema. Now I have dropped the schema, right? I can see as of now, but if I refresh the page, now I cannot see the schema, right? And now if you want to restore, we can just use the command undrop schema carprem. So now my schema is successfully undropped. Now if I am doing refresh, I can see my carprem schema is restored. Same way I can also drop the table named car new inside my carprem schema and I can undrop. So yeah, so in this video we have seen how we can make use of time travel and go back to the specific timestamp. Hello everyone, in this video we'll discuss about failsafe mode in Snowflake. Failsafe provides non-configurable 7-day period during which historical data may be recoverable by Snowflake. This period starts immediately after the time travel retention period ends. However, long-running time travel query will delay moving any data and objects like table, schema, and database in the account into failsafe until a query completes. Failsafe is a data recovery service that is provided on the best effort basis and is intended only for the use when all other recovery options have been attempted. Failsafe is not provided as the means for accessing historical data after the time travel retention period has ended. It is for use only by Snowflake to recover data that may have been lost or damaged due to extreme operational failures. Data recovery through failsafe may take from several hours to several days to complete. Let's now understand when data moves to failsafe period. Let's say you have created employee table in day 1 and inserted 3 records. In day 5, you have inserted 5 records. Now in day 10, you have updated on 2 records. Now let's say you have set default retention time period to 12. In that case, your day 1, whatever you have created, that will be deleted on day 12. Hence, your time travel ends in day 12. That means whatever changes you have made, if you want to recover the state of the data that was present in day 1, that cannot be done using offset or before command. So on day 13, whatever data that is present in day 1 will be gone to a failsafe mode. So in that case, you will not be able to recover the data. You can recover data by contacting to Snowflake.